So continuing with the whole applications of integrals thing, we already saw how to do the integrate the rate, you get the net change. We saw how to integrate the velocity, you get the displacement or the absolute value, total distance. The other applications in this unit are all geometry-related applications. And the first thing we need to deal with is area between two curves. You know how to find the area between a function and the x-axis. That's just an integral. But we need to make these a little bit more involved than just that. What if it's in between two functions? So for our first example, we're going to try to find the area bounded by y equals x squared and y equals x plus 2. What would be really helpful to start this?
Draw the answer.
Okay, of course, the answer, but I would really like to see what this thing looks like. So I'm going to do this. I'm going to sketch a graph of these things. Now, usually, they're going to be complicated functions. We're going to sketch them on the calculator. But I think for this one, we can do the sketching by hand. It shouldn't be too bad. And when you get to the homework, there will be 1 or 2 questions that do say, do this without a calculator, because that'll be prep for the non-calculator part of the AP exam. I'm going to go and draw a little graph over here. Oh my gosh.
This isn't a math class, this is a math.
We don't want the other classes thinking things about us, right? Okay, we gotta go. Y equals x squared. Well, let me plot some points. I know it's a parabola. I know I have 0, 0, 1, 1, 2, 4. I'm hoping that'll be good enough, but then negative 1, 1, negative 2, 4. And I've got a parabola. We know what x plus 2 looks like. It's a slanted line with a y-intercept of 2 and a slope of 1. So I'm over here. I've got a point over here, another point over here. Oh, that's nice that I see them intersecting. Then down 1, back 1, down 1, back 1. I see them intersecting over there. And I've got a graph like this, and I'm trying to find that area. We're going to need to know where they intersect. And I think here we can basically solve by graphing by hand. We saw where the points intersected. This point is what? 2, 4. And this one was what? Negative 1, 1. Again, usually we're just going to use the graphing calculator. Just about every other example we're going to look at today, we're just going to go straight to the calculator to get the graph. Well, here's the idea. If I go do the integral from negative 1 to 2 of x plus 2 dx, that's going to find for me the area under that slanted line, starting at negative 1 and going to 2. Which I don't think is a bad place to start. Between your slanted line and the x-axis. What's wrong?
You got stuff missing.
That's actually the complete opposite. I've got too much stuff here. I've included too much area. I need to subtract some area. Like what?
Like those bits that aren't in the parabola.
The area under the parabola. If I take that problem and subtract the integral from negative 1 to 2 of x squared dx, I will have taken that area. I'm going to subtract from it, well, something sort of like this area. These are not drawn to the best of scale, but whatever. And wouldn't that then leave me with what I actually care about? That should give me, well, let's see, this thing should give me that region that I actually want. Do I actually need 2 separate integrals? No, because they've got the same limits, I can use my properties of integrals that say this is just the integral from negative 1 to 2 of x plus 2 minus x squared dx. And then we'd integrate.
That looks like a parabola, right? It's one of the quadratic something.
Huh? Okay, we're going to integrate this thing. We certainly could integrate this thing by hand, but I don't have the time for that right now. So go to your calculator, integrate on the calculator. There, again, though, there will be one in the homework that we do ask you to kind of do by hand just to get you that practice for the non-calculator part. Go and integrate this thing, and then we'll kind of generalize the ideas we're seeing here. I wouldn't bother at this point with storing anything in y1. I would just go integrate from -1 to 2 and then type in x plus 2 minus x squared dx. 4.5 or 9 halves?
Because fraction should be underneath decimal.
Well, sure. Do we see what's going on here? Too much area. Take something away from it and we get the area we actually want. In general.
Can I send a message to you?
No. To find the area, please, please. To find the area between two continuous functions, f of x and g of x. To find the area between two continuous functions, f of x and g of x. I'm going to say that this thing over here is f of x. Maybe this thing over here is g of x. I want to find the area, not necessarily bounded by them, but just over some sort of interval. If f of x is greater than or equal to g of x on the interval I actually care about from a to b, which is what I see in that drawing that I just gave you. F of x was the higher function. Then the area between them is, so I'm trying to find this area over there. My area is going to be the integral from a to b of f of x minus g of x. We're just going to subtract two functions, and we're going to integrate over the interval that we're looking for the area over. Our formula is a equals the integral from a to b of f of x minus g of x. There's actually an easier way to talk about this, though. Instead of calling it f and g, how about I just call one the top function and the other the bottom? All I need to do is integrate over my interval the top function minus the bottom function, and I'm going to get the area in between them. There are a bunch of little variations of this that I kind of need to show you, but this is the basic idea. Top minus bottom. All right, I'm going to give you a moment. And then we can probably get at least one more in before lunch. Move this up a little bit. Let me start writing the next one. I want to find the area bounded by f of x, which equals x over the square root of x squared plus 1, and g of x, which equals x to the fourth minus x. I want to find the area bounded by them. Usually it'll say bounded, so in between them. Other times I might say over an interval from like 0 to 3 or something, and then we'll deal with that region when we see that. Do you know what those look like?
No.
Go to your graphing calculator. Go to the graphing calculator, get a good picture of what it looks like, and sketch the region. In the homework, the first part of each problem will be draw a sketch of the region. So let's get a sketch. You're going to have to mess with the window a bit, I think. I actually feel like if you go from maybe 0 to 2 for the x's, or maybe -1 to 2 for the x's, maybe -1 to 2 for the y's, that might be good enough. Let's see, f of x, I'm getting something kind of like this for the f of x. Focus, please. And you also then have one kind of like this. I'm going to call that one g of x. I want to find the area in between them. One of the points of intersection is really nice. 0, 0. The other one is not. And remember that because we're going to be using this number and I want the final answer accurate to 3 places, give me more than 3 places here to make sure the final thing's good. Yes, I would like you to sketch what you see on your calculator. Not draw it by hand, but just copy over what you see on the calculator.
Wait, but isn't that drawing it by hand?
No, not like plotting points. Not like how we graphed the first one, where I was plotting. You're going to copy over what you see.
But you're still drawing with your hand.
Oh gosh. Maybe like 1.1807757 for the x-coordinate. And you know what? I don't even care about the y because it's not going to matter for my limits of integration, so let's not bother. Yeah. Oh my gosh.
Wow.
I'm going to integrate over my interval here, which is 0 to 1.1807757. What are you looking for? Oh, good. Okay, now. Okay, stop.
Sawhills is 12.
Hush. What's the top function here? F of x or g of x? How about I just call it f of x rather than actually writing out the whole thing? The other one is g of x. So the problem I'm going to do is f of x minus g of x. We've talked about this before. You can either use x over square root of x squared plus 1, or you can use f of x. What you are not allowed to use when you write this out, y1, y2. They call that calculator notation. They wouldn't accept it on the AP exam. I think you can go do this calculation, though, on the calculator. I would store f of x in your y1, store g of x in your y2, just like what you kind of just did in the calculus and context stuff with the 2 functions. Store them in there. Do your integral. Maybe we can get an answer before the bell rings for lunch. Maybe. Yeah, it's a very small. Okay. Say how did you get that? Because I already did this one out. Well,
IG period.
Oh my gosh.